What is the transmission control protocol features? First is the data is reliably transferred from the sender to the receiver. It is reliable. That is, there is no loss of data or packets. Flow control is there, that okay, 1, 2, 3. If it is sent, then they will reach as 1, 2, 3. Even if it reaches at say 1, 3, 2, the transmission control protocol, it is its duty to make it 1, 2, 3, and then the receiver will accept it. Error control, because it has a checksum. TCP has a checksum. So checksum will decide, because at the receiver sends it, and the sender sends it, and the receiver knows, okay, it is going to test for the checksum, and if some error is there, then retransmission can be there. And finally, congestion control. Now, if so many packets are going, or so many, you can say the content is going, then there can be congestion. It is always possible in network. So the congestion control is also the feature of transmission control protocol. Whole of your internet is on the TCP. So what is the header format of TCP? This is the header and this is the data. Means the content is being set here, but the header is important. Header, the header has the first thing as source port address. It is of 16 bit. Then we have destination port address, which is of 16 bits. Then we have sequence number, acknowledgement number. Then we have something called, which we are just going to discuss, that are the flags. Then this is the window size. This is the checksum for the error control. Then the urgent pointer. Then we have options and padding. Let us go and discuss them. First is the source port address. What is this? It identifies source port of the application process on the sending device. So what is the port? Means if this is the device, which is the port which is actually sending. So the port address in 16-bit is written here. Then we have destination port. Now if you want to send it, you have to have some destination. So what is the port which is going to accept? So it identifies the destination port of the application process on the receiving device. Then we have sequence number. That is this one. This sequence number is of 32-bit. That is the sequence number of data bytes of a segment. Like this is the first one, this is the second one, this is the third one, like this. So this is sequence number of 32-bit. This is a session, or in a session how many now the content is going, and how the numbers have proper arrangement, and it will be accepted in that particular arrangement only. Then we have acknowledgement number. Now this ACK, if you work with TCP UDP, you will always see this ACK. This is for acknowledgement. This is, you can say, an acronym of acknowledgement here. So when ACK flag is set, this ACK flag is set, this is the acknowledgement number, 32 bits. And when it is set, this number contains the next sequence number of the data byte expected. And this works as what? As an acknowledgement of the previous data received. And data offset. We have data offset as 4 bits. So this field, this is the field, implies both, that is the size of TCP header, which is 32-bit words, and the offset of the data in the current packet in the whole TCP segment. Then we have this reserve bits. Reserve bits reserved for the future use, and also they are set 0 by default. Then we have these flags. If you see these are in orange. So URG, the first one, it indicates the urgent point. URG is for urgent. Urgent pointer field, that this has significant data and this needs to be processed in urgency. Then we have ACK, acknowledgement. So it indicates that acknowledgement field has significance. If ACK is clear to 0, this indicates that packet does not contain acknowledgement. Then we have PSH. This is for push. So when set, it is required. When it is set, push is set. It is a request to the receiving station to push the data as soon as it comes or arrives to the receiving application without even buffering it. So push it. Then we have RST, and that RST is, we want the connection to be restarted. It is used to restart a connection. Then we have SYN, that is for synchronization. This flag is used to set up connection between hosts. Then you have FIN. FIN This flag is used to release a correction and no more data is exchanged thereafter. Once it is done, no more data, because packets with this SYN and FIN, these two flags have sequence numbers, they are processed in correct order. Then this is the window size. Again, window size is of 16 bits. So this field is used for flow control between two stations, and this indicates the amount of buffer, that is in the bytes the receiver has allocated for a segment. How much size, how much data is the receiver expecting, not more than that. So that is the size. Only this window size is sent. Then we have the checksum, and you know this checksum, this is the field that contains, or this field contains the checksum of header, data and pseudo headers, and this is how the error control is done. Then we have urgent pointer, URG. As we just saw, it points to the urgent data byte if URG, this flag, is set to 1. Options, now these are options in blue, options and padding. So it facilitates additional options which are not covered by the regular header. So option field is always described in a 32-bit word. So this is 32-bit word. If this field contains data less than 32-bit, then it is padded. So padding is used to cover the remaining bits to reach the 32-bit boundary. That is why it is 32-bit word always. Therefore, we have a word called padding here.